Good morning, everyone. Hi. Thank you very much for your patience. I've been working in technology for over 30 years, and this is what happens every time. And every time I learn something new, that I should never try to park in Hilton Hawaiian Village. But anyway, so my name is Terumi Laskowski. And I'm half Japanese, I'm half American. My dad was in the Air Force, I was in the Army, right, all that. I was in Japan last week, so I'm a little bit jet lagged. I hope that's okay. So right now, it's like 4 in the morning for me, okay? Anyway, so for about the past 3.5 years or so, when all the craziness happened, I stopped traveling and I stayed in Hawaii, and I didn't step a foot out of Hawaii until last week. And while I was actually at home teaching and consulting online, because I am a security consultant and I also teach for AWS and Google Cloud Platform, I've just noticed that there were a lot of customers, the enterprise customers from Seattle and other places, that was requesting me to create a class or 5-day class or 10-day classes on DevOps. I said, what's up with that, right? It's started maybe about 2 years ago. And I've just noticed a lot of people were just interested in DevOps. And DevOps is nothing new, but I just wanted to share with you my experience in working in DevOps for the past 2.5 years or so, creating these courses for customers, as well as a lot of people are moving into DevOps space. And I want to share with you what type of people are moving into DevOps space. What do you have to have as a background to be successful in DevOps, let's say, career? If that's what you're looking for. So I want to kind of share that with you. And if we have the time, I'll share with you a webinar that I did on SDN, so software-defined network. It's a little bit technical, but it's, I'm hoping that you'll find it interesting. So anyway, so let's just go with the title here, Security at the Speed of Cloud, right? And you'll find out speed is really not my thing, right? I don't go fast anywhere. Right? I'm pretty slow, okay? And I think that probably has something to do with the fact that I was an MP. I was a military police officer, and I've encountered many accidents and things. And when you have accidents, speed really does matter, right? So when you're moving fast, it really is pretty devastating compared to if you're just kind of moving along like a turtle and just bumping somebody right in the back, right? So maybe that probably had a little bit to do with that. But speed is going to be the key word for this session, because DevOps has a lot to do with speed, velocity, okay? Anyway, how to maintain control of security in the age of DevOps and cloud. So DevOps doesn't need cloud, and cloud doesn't automatically mean DevOps, but because a lot of customers are moving into cloud, at the same time they are reorganizing their organization, their development and operational organization into DevOps organization. So all these things are happening at the same time. So a lot of people will actually implement DevOps in the cloud because it just happens to be going in the same direction. Okay, so it doesn't necessarily have to be that, but I'm just going to show you. I thought I was right. There you go. The day never ends until we have a little happenings, right? So the goal here is for me to highlight some challenges of implementing security, IT security, in the CI/CD context in the cloud. Okay, so it's a combination of DevOps, CI/CD. So I'll be explaining these terms, as I go forward, and offer some solutions forward, because I just don't want to, complain and tell you there are no solutions. I think there are. Some sensible solutions, because I've just been in IT, I've been in IT for over 30 years, and security for over 25 years or so. And I've taken up roles all the way from, being a systems analyst, all the way to being a systems manager, and then becoming head of consulting in some American companies in Japan, and then going rogue, I guess, freelance, okay? So that's what I want to share with you. And the agenda here is, first, I want to explain what DevOps is. I think there's a lot of definition of what a DevOps is. So I'm just going to give you my version of it. And then CI/CD, which goes right along in DevOps. and security of the CI/CD pipeline, and security of and in the CI/CD pipeline. So these are two different concepts, but they go together. And then issues of security in the cloud and virtualization, if we could get to that part, okay? Because that's cloud. Cloud is all virtualization. Okay. All right, so here we go. Of course not. All right, so I think that's all the slides that I have there. Let me go back there. Okay, so I want to kind of start from the beginning, right, of this story. There are a lot of things that actually was happening, many, many years ago, like 20, 30 years ago, that finally everything is kind of coming together. And everything is like kind of blowing up, so to speak, in the DevOps space. Same thing as, some of you probably noticed how AI is really like, taking off. Right? I mean, there seems to be like brand new something happening in the AI world like almost every day. It's pretty crazy. Even ChatGPT, right? They have GPT Turbo or something, right? Something crazy like that, okay? So now, DevOps isn't moving that quickly, but it's been kind of moving, like I said, for the past 2 years or so. And they all, I think, have root in waterfall model. For those of you that's been working in the military, and working in the project space, you probably know waterfall model. Unless you are quite new to the space, maybe you don't, maybe you do Agile now. When DoD started to kind of tout Agile rather than waterfall, I was like floored. I said, what? You guys are moving into Agile, right? Because when I was actually working as a Navy rep in Japan at the U.S. Embassy, and I was a U.S. Navy rep doing projects, weapons, cooperative projects with the Japanese Navy or Maritime Defense Force. Okay, and the projects moves at snail's pace. Right? And the reason why I got out of that job in 4 years is because I just knew that it just wasn't me. I wasn't going to wait 10 years for a project to finish, right? And there was already a project going on when I joined the organization, and there's a project going on when I left the organization, I only saw one finish. And there's like a whole bunch of stuff in the air. And that was, I think, partly due to waterfall model of the way that the military used to do projects. And it's so nice that, they are now moving into Agile space as well, right? Anyway, so let's talk a little bit about Agile, okay? Here we go. All right, so we'll talk about the overview of software development lifecycle because that's actually at the beginning of everything. Then we'll talk about Agile, and then we'll talk about the waterfall and how they compare. And the point that I want to kind of take over from this module is the Agile, because Agile is the one that's going to come to the forefront when we talk about DevOps. Okay, all right, here we go. Yes, okay. So the key concepts here, SDLC, waterfall project management methodology, and Agile methodology for project management, okay. And here we are. So what's SDLC, right? S stands for software or systems. So it could be systems development lifecycle or software development lifecycle. And I have a chalkboard right there, right? It's a process used for planning, creating, testing, deploying, right? An information system or software into production. Right? So that's basically what SDLC is. That usually I have the 7 steps on the right. That's just one of the steps that I usually kind of draw out when I'm explaining SDLC. So it all starts out with a systems requirement from the customer, the business owner, whoever's owning the system. And then it goes through the architecture design, then it goes into development or coding, and then you have a QA testing, that stands for quality assurance testing. Then it goes into deployment, then operation, and then hopefully, happily, end of life at some, long years later. Right? So this is the complete cycle. And in any type of project management that I've experienced, whether it be waterfall or Agile, we still follow these steps. It's just that we do them a little bit differently, right? How do they run together? That's the difference when you're talking about Agile and waterfall. But anyway, so it does have several distinct steps. And, you may have some people that give you 5 steps, some people give you 8 steps, okay? But it's generally this. Okay, so, and I hope that you probably recognize if you've gone through any of it. And normally, up until Agile became very popular, you would specialize in one of those areas. So if you are, systems requirements person, then you would be called a systems analyst. and you are good at talking to end users, business people, you know how to turn business language into system language, so that now you could pass that requirement down to the architect who knows, they don't know how to talk to people, right? So this is the journey that starts, right? As you go down on the SDLC, and less these IT folks are able to speak to like regular folks, right? So they're like so nerdy, okay? I can say that because I was in there. I'm not anymore, right? But anyway, so that's basically the flow, okay? Oh my God, if you talk to developers, you say, hey, what language do you speak? They say, hey, I speak Java, I speak Python, I may even speak C, right? Okay. Crazy folks. But anyway, so that's SDLC. So it provides a very good structure when you are managing projects and say, okay, what do I do next? And then what do I do next? And then what do I do next? Okay, so that's SDLC. Now, how do you actually conduct SDLC? How do you actually move it forward, right? And this is where we use some project management methodologies. Okay, so let me do that. Now, by the way, because I'm a security person, I don't want to forget that. See that pink part? That's security, okay? So security is at the every phase. It truly is. So if it's at the systems requirement, you talk about, well, what is a security requirement for this system, right? So if it's architecture design, you say, okay, so what is the security architecture requirement for that? If you choose cloud, you got a bunch of stuff that you have to think about. If you choose peer-to-peer, you have to think about a whole bunch of other stuff, and there's always something to do for security people, right? Okay. Development too, and let me kind of mention the development and what they do here, okay? Development, the coders, right? Programmers, what do they do from security? Well, they actually don't do much, and that's why I think we have had software that has lots of vulnerabilities, because they just was not educated, and not because they don't want to learn. It's because the companies don't pay them to go to school and learn about secure coding, right? So they have to be taught because it's not intuitive if you're not a security person. Right? And I'm a security person, and I have specialized in application pen testing. So that's basically a customer will give me a URL, says, hey, there's that website, see if you can break it, with permission, of course. Right? I don't want to go to jail. Right? So security folks are generally in breaking things, right? Or breaking into things and revealing things that you're not supposed to see. Whereas the developers are into building things. They like to make things, right? They manufacture things, right? So they have the two complete different mentality. So when you talk security to application developers, their eye glazes over and say, but I just want to be coding, okay? So that's the kind of developers that I used to know, but it's changing. Okay? Anyway, so then you have the rest of the flow. And security is at every phase, right? QA testing is pretty big for security, because usually if you do security testing, you do it at the QA phase. That's the traditional place you do it. So if you've heard about dynamic application security testing, DAST, if you've heard about vulnerability scanning, pen testing, all those things usually happen around QA testing phase. Okay? But we do actually have legitimate work as a security person in every phase. Okay, just to kind of let you know about that. All right, so let's talk about waterfall model. So now you take that SDLC and all the things you have to do and try to overlay that onto that little, waterfall that I have onto the right. Okay, so it kind of, everything flows down. Okay, so the systems requirement starts at the top, and the operation goes at the bottom, and you have everything in between. Right, and the point about this is that it's actually one-way direction. That is, if you finish with the systems requirement, you go to the architecture, you don't go back up, right? So you don't swim up the stream or swim up, the waterfall, right? So that's usually the rule. So that means once you know what it is that you want to create, you keep on going down, 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 down. Okay? And if you try bravely and say, I think somebody forgot something. I'm a developer, and I think the systems requirement people forgot something. I think I have to let them know. Sorry, usually those people are already gone. They're on to another project somewhere. So they're not there anyway. Okay? And it's not allowed anyway in the process. Officially, you can go back, I think, all the way up to 2 steps before your step. but you can't go back up any further than that. I think that's like the official standard waterfall model rule, okay? So, but what happens with this is that, if you're looking at this and say, okay, if you can kind of imagine like in military projects and stuff, they have like real long time for things to finish. Have you ever seen these projects that took like maybe 3, 4, 5, 6, 7 years, right? And then when it comes up, maybe it's a weapon system or something, and when you see it and you say, oh my God, why do you have this, like CPU in here that's like way old? Like what's going on here? My iPhone has a better, CPU than what you have in your whatever, right? Name your weapon system, okay? All right, so anyway, I'm just joking, of course, but, I was kind of surprised when I saw what kind of an IT system that was in one of these, airplanes, not the military ones, and I said, oh my God, that's pretty kind of simplistic thing that you have in there. Are you flying airplanes with that? And, like I have an iPhone, right? Can I like remotely control this thing, right? So, and I think that's because technology is moving so quickly, whereas the requirements was set like 5 years ago, right? So, and this is getting worse now because you set it, let's say 5 years ago, and 5 years' time, many, many other things are happening in the world. Everything is kind of accelerating, but the waterfall model kind of stays still, right? Okay, so what's happening then is that the assumption of the waterfall model is that when you're standing at the top of the waterfall and you're looking across and say, what I want, I have a clear vision of what it is that I want, yeah, okay? Then you set your requirements at that time. Right? So let's say 5 years ago, 10 years ago, okay? But that requires you to not change anything because you cannot go back to the requirements phase. Once you get this ball rolling down the waterfall, you can't go back up. So what happens then is that inevitably things change. Life change, the environment change, the technology change, and yet your project remains the same, okay? And what I have in here is this right here. The issue with a waterfall model that I see is that, look, can you predict the future, right? And chances are, I don't know, I don't think I can, right? I have no idea what's going to happen tomorrow in the AI world, let's say, okay? So with that, you use a waterfall model and you pretend that you know what's going to happen and you know exactly what you want now where you're going to be receiving, let's say, 5 years later, okay? And that has, in some people's view, become very ludicrous and says, oh, wait a minute, this doesn't work, okay? Because we don't know the future, so we have to change this model. And, there's I'm not a project manager, but, some project manager says that, look, you want your project to be on time, in budget, and in spec, right? Those three things. And the joke is you can never have three things at the same time. Right? You can only have meet two of the things, like maybe it's, in spec, on time, but, way over budget and stuff, right? Okay. And I think it probably has something to do with the waterfall model as well. Okay. So then there were several people, I think it was like 12 or 17 people, I actually forgot, came together in some ski resort in Colorado, I believe, and back in 2001, and came out with this manifesto that says, it's called Agile Manifesto, right? So, it's on the internet, so you take a look at it, okay? I'm I'm actually a Scrum Master, okay? So I was trained to, actually do project management using Agile principles called Scrum, okay? And what I learned was very simple, like how would you explain Agile? And the explanation of Agile is, put waterfall on its head. Right? So everything opposite of waterfall, they like to do in Agile, okay? So if you want to say, I can see the future, the Agile says, I cannot see the future, right? Things change. Even the customers change their preferences. If they think they want something, tomorrow they want something else, right? So we need to be flexible, so flexible that we are only going to run our, what's called a sprint, for maybe like 2 to 4 weeks, and we're going to come up with an incremental product called MVP, minimum viable product, okay? Then when we're finished with that, we're going to go back to the user and say, hey, what other little piece would you like? So it's an incremental development, okay? And everything is incremental, and everything has to finish within a sprint. So that's like 2 to 4 weeks. That's the standard length, okay? So then you go through pretty much an SDLC in that 2 to 4 week spin. And then if whatever comes up doesn't look right, well, you go through the sprint again, okay? And then once you have that little piece out the door, now you pick another little piece called a backlog, and then, backlog is a priority of features and functions that the users want, and the developers will choose and say, I think I could do that in 2 weeks, I think I could do that in 4 weeks, and they'll grab that piece, and they'll start the sprint again, okay? So that's basically what an Agile principle is, okay? So basically, if I were to kind of put this down, Scrum is a methodology. It's an Agile framework for project management. And within that, there's something called a sprint, okay? And without even reading what the sprint is, it's that picture. So you go around once. That going around once is like 2 weeks. That's a sprint, okay? Then you go to the second sprint, the third sprint, the fourth sprint, right? And one thing to remember is that these sprint teams are very, very small. Okay, so if you're used to having developers that are like 10, 20, 30, when I was in Japan, I saw like 100 people, coming over from China to do a Japanese banking project. There's like, whole floor full of developers. Here, one of the AWS tops said that if you order 2 pizzas for lunch, and if it's not enough for the developers, then your team is too big. Okay, so what they're saying then is that your sprint team should be around 4 people, American size, right? I think with Japanese size, maybe like 10 people, I don't know, right? Okay, but anyway, so we're talking about 4 to 5 people, so it's a very small team, but they're very independent. So once they have the mission to create something, the MVP, they have the freedom to choose the technology that they want. They have to choose anything they want to get the job done, right? That's the freedom that they have, okay? So that's basically what a sprint is. And I actually have a animation here. So it's a sprint, right? So it's fast, okay? And it's short distance, right? Okay, so it's incremental. That's basically what Agile is. Okay, and so now I hope you see the difference between waterfall and Agile. So then, where is that leading us? Okay, well, it's actually leading us to the next point. Let me go to the next slide, to introducing, finally, to DevOps, right? DevOps. So what in the world is DevOps? So here we go. So we'll talk about, understanding, what DevOps is, and then looking at the relationship between DevOps and SDLC, and all the stuff that I've just been talking about, like the waterfall and Agile, and all that will come together pretty soon, okay? And understand the key components and benefits of DevOps, right? Here we go. So the key concepts here, we'll talk about DevOps, SDLC, and then we'll talk about CI, continuous integration, CD, continuous delivery, and another CD, continuous deployment, and then infrastructure as code. So these are these key words that you find in DevOps space. Right. So DevOps, what is it? It's a set of practice that combines the software development and IT operations together. So, on the right, you see the familiar SDLC. And notice where I said combine, right? So that piece, that little pink piece, is DevOps, okay? And what the DevOps is they're trying to combine it. For what reason, okay? They want to make it streamlined, right? Take away the barriers, if there are any barriers between those teams. Remember, it used to be that the developers were not QA tester, and they were not deployment, and they were not operations. They were different departments. Everybody was doing separate things. So, but you still need coordination to do SDLC. So as you go through the phase, you have to coordinate and say, hey, I'm almost done. So when can we schedule a QA, folks, right? Because if you find something wrong, you have to bring it back to me, the developer, so we can fix it and stuff. And then it takes like, days and weeks to kind of set up those things. And then once they finish with QA, you have to kind of talk to now the operations people who's going to deploy your solution to, let's say, production. Okay. That also is pretty risky because now you're putting something new into something that's working, right? So it may just like mess up the whole thing. So, development people, operations people are pretty, I think, conservative people. They're risk-averse people. because they've just, they've just seen too many horrible things happen when new things come in and they break, right? Okay, and they are the people point fingers to them and say it's your fault because you're responsible for operations and now it's not working, right? So there was a lot of miscommunication there, and it took a lot of time. So in order to speed up the whole process, they say, look, let's make that into like a one big block of space, okay? And the point here is that it's speed, okay? So why do you think that certain people wanted to combine that, streamline that, and increase the speed of the SDLC? Why do you think that is? Anybody? Yeah.
Faster you get out, the faster you get paid.
Oh yeah, there you go, right? Yeah, so that's the concept, is that looking from a business perspective, not from the, the systems people, but from the business perspective, the newer things go quickly into production, that will go into the end user's hands, and if the end user are happy, then they'll pay you for it, right? And they're really happy. So salespeople are happy, the end users are happy, so, but what are you doing in the middle where when you have a new code that was written and committed, it's ready to go, and yet it takes like days and weeks for this thing to go through the process. So that can't happen, okay? That just seems like waste of time. Communication, fix it. Okay, so I think it was very much a business-driven, endeavor for DevOps, right? Okay, so increasing communication, taking away the barriers, et cetera, find all the ways that you can actually streamline. But when I was, when this thing was kind of taking off, I'm talking about maybe 10 years ago, okay? I was teaching this thing called CISSP. So CISSP is a security certification for consultants and stuff, and I was kind of teaching that course. And I would have this big, fat knowledge-based book, okay, that the ISC Square, which is an organization that offers CISSP, has. And I looked at DevOps, right? And they said, DevOps equals no security. That's what it said. Kind of, sort of. I'm paraphrasing, but that's basically what they said. So I listened to all my peers. Okay, DevOps means no security. What? Okay, so why would there be no security? Because in the regular phases, all those places that you combine do already have security. Remember I told you, you do security at every single phase. So just because you're combining, why would you say no security? I just didn't understand, right? There must be security in there. But sure enough, as companies started to do this initiative, they've actually tried to automate the thing, right? Because automation really makes things fast, right? Take the person out of the loop, and that's it. You have no fat fingers, and there's no more mistakes, and just take them out of the picture, right? Just go ahead and automate the whole thing. And you know what happened back then? Right? Automation requires that it's called APIs, application programming interfaces, with the components within the DevOps. Okay? So if you're moving from development to testing to deployment, whatever the automation tool that you're using have to be able to be integrated together as another program. Okay? But guess what? These security tools that I was using was not automatable. There's no APIs for those tools. You pay expensive money, pay a lot of money for the licensing, and then it sits right in front of you, and you start typing away, and you start clicking the things, and it's GUI, and I have all my tools. So I saw myself kind of injecting myself as a human, right? But that was contrary to what the trend was. That is, no human, all automation. Oh, so there's no security tool that you can actually automate? Hey, we can't stop progress, so let's just go ahead and move forward. And they, a lot of companies bulldozed their way forward and left the security in the dust in a lot of cases, right? Now, if they truly understood the value of security, and if they really understood what they were doing, was that now they were actually producing vulnerable software at a, the speed that you just can't even imagine. So now they're spewing out all kinds of applications that did not go through proper security testing because they were using DevOps, right? So let's go fast. And some people kind of justify that and say, oh, if you know the term refactoring. So refactoring means something completely different than what a lot of people use. But the way people explained it was refactoring is we put something out in the front. If something's wrong, we'll take it back, we'll fix it, and then we'll do it again. And every time we refactor, we won't change how it looks and feel, but we will change the inside. We'll maybe add some things, and we'll optimize the code, and we make it better. And you know what? One of those things that they did at the end, if they remember, was put security in. Right? So things will go in, security goes in last, if it ever went in at all. Okay? So anyway, so DevOps, that's, and from that perspective, I said, okay, yeah, DevOps means no security. Okay? Sort of, right? Yeah, it was pretty interesting times. It's not like that right now, though. It's not, okay? It's different now. And when we're talking about security in DevOps, a lot of people talk about DevSecOps, okay? And I just found this to be really, interesting, okay? Because, like I said, DevOps, if you do it right, already has security in there, right? Because between Dev and Ops, you got QA. And like I said, QA has security testing all over the place. So you don't have to say DevSecOps. I know that security is in there. But you know what? A lot of people still feel like they have to say DevSecOps. Because of what I just mentioned, is that if you don't put security in there, people just says, okay, I guess we have an option. We do the dev and we do the op, and if the security tools ever catch up, we'll put a sec in there, right? But automation and speeding up the process is the first priority. I hope I don't sound like, I'm complaining. I'm not, right? I'm just kind of describing the experience that I've had, right, over the years, okay? But anyway, so the part that I want to focus right now is development and QA testing, even though I know that security exists in other places as well, okay? So I have on the right-hand side the security testing during DevOps, okay? Because this is where, I guess security people receive a lot of attention these days. Okay, so there's two types of testing. One's called SAST, and the other one's called DAST. The SAST is static application security testing. Okay, and a lot of people will call that code review. That's another term for it. Okay, DAST is dynamic application security testing. Okay, the major difference is one, who will do them, and two, what is the state of your application. So with the SAST, the application is not running. So you just see the source code. And normally it used to be that, a very, astute programmer will look through the code and then find places where there may be some security vulnerabilities, right? But those days are gone, right? So we use scanners these days to kind of assist us because there's so many lines of code, it's pretty crazy, okay? And because there are a lot of things going through the pipeline. So we use tools to do SAST, okay? And it used to be, right? When I first started doing application security, we as a consultants will go in there and do a SAST for the customer. Because we just didn't have enough people that were programmers who knew about security that can actually do the job, okay? So we used to do that, but not anymore, okay? And so SAST actually happens usually around, it used to happen at step 4, but these days, for a reason that I'm going to explain, actually happens at step 3. Okay? So that's where SAST is going to happen. Then you have a DAST. So dynamic application security testing is normally what you would do in the QA phase. So this is when the application is actually running. So you actually have to have the server, you have to put the applications in there, right? And then the security tester will actually throw everything in the kitchen sink at the application and try to break the application from the exposure that it has, right? So if the user has a front end, the front end is exposed, we'll kind of throw all kinds of things in there. We'll do SQL injection, cross-site scripting, all that stuff, okay? And then we'll try to break it. Ready? Okay? And that we would do at step 4, and QA tester, security tester will usually do that. Okay, so those are some typical testing that we would do. And like I said, initially those tools were not automated. They were manual. So that means if the companies were going DevOps, but we still had tools that were manual, those testing became fewer and fewer. So I've noticed that one customer will classify a certain project as being critical and non-critical. And the non-critical ones, they say, okay, the team will do the security testing. Okay? And in the critical ones, which are very few, was allowed to take more time because the security folks had to go in there manually and do these testing. So that's how they kind of got away with it, right? But that customer didn't actually have such a great experience. Okay? Because the application, if you leave it up to people and says, oh, you're responsible, I'm just going to watch it. Oh, here's the guidelines. Okay? To someone who's never done security before, they're not going to do it right. Okay? They'll try their best, but they're not going to do it right. Okay? That's my experience. Okay? Now, the part that I actually want to bring your attention is the left-hand one, right? So where you have DevSecOps, and I have DevSecOps is continuous security, right? Continuous means automation. That wasn't happening for the longest time. And then you have automation because we need velocity, and then collaboration and communication, and security folks, starting from myself, was not good at it, right? Because for the longest time, security were very niche. And there were a lot of the managers would just leave the security and say, oh, yeah, just go to the security people. They must know what they're doing, right? And God knows, I don't know how to talk to them. I think Terumi is speaking Japanese. I don't know what she's talking, right? Anyway, so that's the way we were kind of, isolated. But we've gotten much better because now security doesn't happen unless security folks evangelize within the enterprise and say, look, it's important. Okay, so we need to be communicative. Okay, but the interesting one is that last one, shift left. Does anybody know what shift left is? Okay, it's not one of these military moves, okay, that I used to do in college. Right? No, shift left is if you take the SDLC, and I kind of drew the SDLC vertically, right? But if I were to put horizontally, then, so like that, right? So then the steps will start from the left to the right, yeah, like a timeline, okay? So if I'm standing right where the developer is standing, to the left of me is everything that comes before my steps, and to the right of me is everything after my step. And shift left is a message to the developer that says, look, you have to start to incorporate security at your level, right? Because security happens even before it gets to you, to the developer. But now you are responsible for doing more of it, okay? Now, at a first glance, it sounds fine. It says, okay, yeah, security is everybody's responsibility. Yeah, why not, developers do more of it because you haven't been doing enough of it, okay? But if you kind of open up the box and look inside, right, developers are not trained to do security. And the type of security that now they're being asked to do is SAST, right? So now they're asked to use these tools and to evaluate their own code using these tools and find vulnerabilities and fix them before it goes to the next step, okay? Now, security it's not rocket science, not the kind of security that I do anyway. It's teachable, you can learn it, right? But is there a motivation for developers to learn that? And I would say some developers are not motivated to do that. Yeah, like I said, they're builders, they don't break things, right? If you're doing testing, you're trying to break it. It just doesn't match their mentality and their frame of reference, okay? So now they're being asked to do something that they never used to do, but now because of all this movement, they say shift left, right? Now you're responsible for security, okay? And it's something that they're not used to doing. And I would say that these companies that will do shift left will do training, okay? But it just doesn't kind of, click, right, with a lot of developers. They just want the code, right? And everything else is something that's taking away from coding, okay? So now they can't concentrate. They have to do like all kinds of different things, okay? But anyway, so that's shift left. And that's the reason why SAST is now moving to step 3. That's the reason why, okay? So here's the thing, right? And I think it was Einstein or somebody who said it, right? So you cannot fix a problem with the same mind that actually created the problem, right? So if you have a vulnerable application and you have an application developer who created it without knowing it, now you're asking that person to fix it. Well, they didn't know in the first place. How are they going to recognize the vulnerability and then fix it? That just seems kind of ridiculous, okay? So you need someone with a different set of eyes. And also from a security perspective, okay, there is, if the developers that I know, and not all developers are like this, but the application that they create is their baby, They don't want it to be criticized, yeah? So if you criticize the application, you're criticizing that person. Okay, so, and they think it's beautiful, they think it's, their best work, and then, you say, oh, that's broken, oh my God, you could do that, oh, what are you doing, okay? And they'll just get very emotional. I don't know why. Okay? So anyway, we're talking about real people here. We're not talking about machines doing these things, okay? So I think maybe that's why a lot of people say, yeah, let's take the emotion out of it. Let's just automate it. I think that's another way too, okay? So anyway, so that's basically what a DevSecOps is, right? So they're trying to put security in there, okay? All right, so let's take a look a little bit more. So SAST, right? It's a way to do security testing that is analyzing source code, okay? And this actually is the best way to do it, I would imagine, okay? Because you have the entire code in front of you. If you know what you're looking for, you can recognize all these vulnerabilities, right? Okay. But the problem is, another thing that's happening with the enterprise is that they're kind of dabbling in all kinds of different languages. So I work with a company that actually has like 5 or 6 languages kind of floating around in their company. They got Java, they got C++, they got Scala, they got Python, they got JavaScript. Oh my God. Okay. And says, well, but what's the problem? They're application developers. They should be able to speak that language. Not true. Not true. So if you're a Java developer, you probably are not a great C developer, okay? Totally different kind of a language, okay? So the fact that there are a bunch of languages kind of, laying around, that actually reduces the expertise of everyone because now they're kind of required to learn the new language like every, 2 years, 3 years or whatever, and they never have the depth, right, to learn one tool very well. So what does that have anything to do with security? Right? Well, if you don't have a deep knowledge about the language, okay, languages actually has a lot of vulnerabilities. Java, for example, has vulnerabilities. C, is there any C programmers in here? That's okay. We're not going to attack you or anything. Okay. Oh, really? Oh, so you don't want to admit that you do pointer language, right? So you do pointer math and stuff? Oh, yeah. Okay. Those pointer stuff is so confusing. It's caused for a lot of vulnerabilities. Okay. C is very down to the ground, and you could do a lot of things, but it's so confusing to look at. And if it's confusing, if it's complex, there's a lot of room for vulnerabilities to kind of sneak in. That's basically basic tenet of security. Okay. So then people say that's no problem. I use Python. Python's pretty secure. Oh yes? Are you sure? Okay. So Python is known to be very secure language. It's true. There aren't too many vulnerabilities in Python that's been reported that's critical. But those vulnerabilities that are found in Python are actually critical. Those few ones are critical. And I think it has something to do with the fact that Python is rooted in C. Right? So the reference language for Python is CPython. Okay, so that means if you're not careful, you could have the problems that you had, like memory buffer overflows and stuff. Those kinds of memory issues in Python because it's rooted in C. Okay, so that means if you don't know the language well, you're not going to be able to use that tool well. So you're not going to know when you may kind of like hit yourself in the head with a hammer, type of speak, right? If you don't know how to use the tool well, and that's also another thing that's happening, I think, in the enterprise, right? It used to be that companies would just like choose one language and say, yeah, we're a Java shop, right? And that's all they do. They'll use Java for everything. But those are pretty few and far between, I think. Okay. So anyway, so SAST, right? You need to have deep knowledge of the language as well as a specialty in security in order for you to look at the code and say, yep, I think that's a problem. I think that's a problem. Not just a coding problem, it's a security problem. Okay. So that's hard to do. You need expertise to do, okay? And guess what? AI, okay? So this realm right here, these days, AI, okay? AWS, Amazon Web Services, has something called Code Guru, okay? And oh my God, I pushed through the source code, and boy, the kind of vulnerability that it found is very impressive. Very, very impressive. Okay? And it does it like within like 5-10 minutes. It's just amazing. If you do it with a human, it'll probably take like half a day. Okay? So anyway, so it's coming. AI is in security. So DAST is the dynamic one, right? So you're running the application, and this is usually performed by security folks. And thank goodness, application developers are not asked to do this part. Because this one, it doesn't take as much expertise as a SAST, But you do need to have some knowledge about networking, OS, right? And if you do Windows, you may not be proficient with Linux. So if you hit the vulnerabilities on Windows side, you may not find the Linux side. So yeah, there's still, some specialties in that area too, okay? Then you have the application layer, right? So the application layer is like, what is it? Is it Windows application? Is it Linux application? Is it a custom application? That's also specialized. I mean, we all like to specialize, okay? So if one is going to do DAS, you have to actually have maybe a couple of good knowledge areas in the field that I just mentioned, either the networking, the OS, or application development, right? So then you'll be able to do these pen testing. Okay, and that's normally what I do. I do DAS, and I do application pen testing. So I'm more of an application person. I teach networking, right? But networking pen testing is now a dime a dozen, right? It's already overrun by tools. And, yeah, I think there's still room for a human to kind of go in there and do some things. But, all the low-hanging fruit you can find using tools. Okay, application space is still kind of sort of open, and my guess is with the speed of AI in security, I would say a good 2 years maybe, and then by that time, if not earlier, I think application space is now going to go into AI as well. Okay, with the speed that I see things going. Yeah, so there you go. Okay, so I tell people, oh, you want to be security people? Oh, okay. Oh, same thing with the programmers. I said, oh, you want to teach your child to be a programmer? Are you sure? Because I think, it's okay that you learn programming because you learn logical thinking. But, that's probably about how far you're going to go in programming space, because now, even now, programs write programs nowadays, right? Okay, Microsoft with GitHub, they have an AI integrated with the IDE, the integrated development environment, that's going to assist you in writing code. Okay, so it's already here, right? Okay, it's not perfect, so we still need humans. Okay, but eventually, I think that job probably will go away. Mark my words. All right, so that's DevOps, right? So now let's go into CI/CD. Okay, so the CI/CD is actually, I kind of skipped it, but CI/CD is the way you automate DevOps. So DevOps is not all automation. DevOps is about communication, lowering barriers, and then using automation to move forward very quickly. Okay, but the automation is just one piece in DevOps. That automation piece is the CI/CD. So it's a tactical way of actually implementing automation in DevOps. Just kind of think it that way. Okay, so if you hear CI/CD, it's about automation. Okay, so here we go. Right, so understand the process and benefits of continuous integration. That's CI. What is continuous deployment? What is a continuous delivery? Okay, and we'll talk about brief, differences between the two. So we'll talk about CI, CD, the servers. I'll talk about testing. So CI/CD, continuous integration, continuous deployment is just a practice within DevOps of automating the process. Okay, starting from the source code. That's where the developers finish their code, and then it's like dominoes, right? Automatically, it moves to the next step. So they'll build the application, like they'll compile it, they'll link it, right? They'll do unit testing. Those things comes after when somebody commits a code. And once they commit the code, if everything works okay, if nothing fails, then something called the artifact is developed, created. So artifacts are like executable files, like something.exe file, okay? Or if it's Python, it's like a zip file, right? Whatever, right? So some application that's ready to be put into a server and run. So that's the end product at the end of the CI phase. So, having an executable is the product, deliverable, artifact of the CI, then who's responsible for CI? CI is the responsibility of the developer. Okay? So the CI phase is mostly developer things. Okay? Then that's where it ends right now. Then if the artifact is like a football, then when the football is ready to go, somebody will kind of catch that football and then run forward. So that's CD. Okay? So now you take the artifact, and then you find the infrastructure that you want to put that in, and you put it there, right? So that's continuous delivery. Okay? Now, there is a difference between continuous delivery and continuous deployment. So the continuous delivery is the line in the center. Okay? Notice that, beanie man kind of standing with a stop sign. Okay? So that is where you have a human in the loop that says, okay, we've done automation all the way up to this far, but you know what? Before we actually, push this out to the world, I think we need to have somebody, human, take a look at it and be responsible for it. Right? So if something goes wrong, it says, oh, it's Terumi. She's the one that released it. Okay? So, but if you look at the continuous deployment, which is the third line, there's no human in the loop, right? So that means as soon as the developer says, I'm done, I got the MVP, minimal viable product, I'm done, okay? Then everything is automated, and it goes out into the world in an automated fashion, okay? So there's no human in the middle. And guess which one most of the American customers are using? Just a CI, CD delivery, or, continuous deployment? Continuous deployment? Yeah? Actually, it's pretty interesting. It may vary depending upon the state, okay? But it's actually, AWS did a survey and asked their customers, hey, which one do you actually do, Because I think automation is in, so are you doing that last one, continuous deployment, where, there's no human touches, any process? And over 50% of the customers actually do the thing in the middle, continuous delivery. And I think it's because they're still kind of testing the waters. They still don't trust the automation all the way. They still want that option of human being in there to take accountability for what goes in. Because once it goes out, it's out. Okay? Yeah. So, but, if it's a smaller projects, and I would imagine if you were more risk-seeking, let's say, startups or something, then you may go the last route. I'm not sure, okay? But a lot of people are still in the middle. So I think that tells me that DevOps is still, maturing. It's not fully matured yet, okay? Even though those two are options. There you go. And one point that I do want to make a point of is that the CI/CD is all about increasing velocity. Increasing the velocity, right? And the frequency of release. So release means that the code that you write goes into production. So that means the end users are actually going to touch it, okay? So some companies, believe it or not, if you've ever been in this kind of process, especially like waterfall, for me, when I was at the US Embassy, release happened like every 2 years, right? Okay, because one, it was a major weapon systems and stuff. We're talking about ships and, missiles and stuff like that, right? I mean, it's like, it takes a long time, okay? Do you know that these folks that's doing DevOps, they release multiple times a day? It's like, what are you doing multiple times a day? Like, why can't you write the code right the first time? Like, what are you doing? Why are you releasing like, 2 or 3 times a day? But some people do it, okay? Mainly because the CI/CD is based on the Agile principles. And Agile principles are incremental development, incremental testing, incremental release. So the smaller the increment, the more frequently that they would like to put that in there, okay? And people will say that that actually produces better code. It says you do more frequently, these releases, yeah, we're not being brash, we're being very, good, we're actually creating better code. Does that make sense? Why would you think it makes sense?
Because a lot of times you're not going to find the vulnerabilities until it actually gets out there. So you don't know what you're doing wrong until you see it go wrong.
Oh yeah, there you go. Yeah. So that's so if you put a security in the mix, that's exactly right. Okay. So if you have a project that you've been writing, and like compiling. Now this is big, humongous thing called a monolith. Okay. And then you say, I'm ready. Well, what if you have a bunch of vulnerabilities in there? Once you release it, you're going to have vulnerabilities, right? So with the Agile, because you're doing incremental development, you're just changing something very, very slight. And then you're testing it. So if you're making small changes, and it worked the last time, but it's not working now, it's probably the new thing that you added, right? So it's easier for you to find mistakes including security mistakes. And then you correct them right there and then. Right? So that's actually one thing that I really like about DevOps and security is this incremental nature. I really like it. And there's a process called TDD. I'm not sure if you know it. It's called test-driven development, where you write the test first before you write the code, and you purposefully fail the first test to say, okay, I haven't written that code yet. That kind of makes sense because you're writing the test first. Then you write the minimal code to pass the test. And if the code passes the test, you go back to the code and you clean it up. So that's like, it's called TDD, right? Some people don't like it, but I kind of like it. It kind of makes sense that test is driving the process, right? And that's how we find security problems too, by testing. But of course, you have to test the right things. Okay. Anyway, so this is the CD. So let's take a look. So CI, right, is a development practice, right? Remember, this is development practice. It's a developer thing that requires developers to integrate code into shared repositories several times a day, et cetera, right? So this is where they produce, as a team, a piece of artifact. So that's a CI, okay? And then we have the CD part. So CD is the ability to get changes of all types, including new features, whatever, bug fixes, into production. That's basically what CD is. Okay? So I hope now you see the relationship between DevOps and CI/CD. Okay? All right. So now let's talk about these continuous delivery principles. Okay? So the continuous delivery principles are frequent small deployments. Frequent small deployments. But then you think and say, but wait a minute. So now you're creating small applications? But we used to need big applications, right? So how do you actually turn big applications into small applications? Well, it's like taking a big rock and taking a major hammer and then just like, cracking it and make it into little small pieces, okay? Some small pieces kind of make sense to separate and some pieces don't. So sometimes you have to keep things together. Sometimes you can separate these things out. And when you take the big thing, which is a monolith, and you make it into little pieces, which are called microservices, and these microservices are developed by the Scrum team, okay, the 2 pizza teams, like 4 or 5 people, then what happens is that the businesses will look at this big piece and say, this is exactly what I want. It has everything in it. Yeah, it's big, but it's kind of clunky, but yeah, but it does everything I want. But due to making things faster, you broke it into pieces. The business doesn't care, right? As long as everything kind of goes out fast and they still get the value that they're looking for. So what you do now is you take those little pieces and then you connect them back together again. That's what you do. So microservices does small things, but group of microservices will be able to do bigger things. And one thing that's different is that you have a monolith that's one piece of code. Whereas now you break the same thing into small pieces. You got a bunch of teams working on it, but individually, they can start to deploy separately because there are individual teams. So if some teams are faster than the other, it doesn't matter. Not one team is going to kind of hold everything back. That's not going to happen. Okay? But here's the security piece. What happens, everything kind of sounds nice. Everything kind of fits into the DevOps, flow of things. If you have small pieces and do Scrum and all that stuff, okay. One problem here is that now the application is distributed, right? Because you have a bunch of microservices that are like all over the place. Now, if you're familiar with containers, like Docker containers, okay, these microservices run perfectly in Docker containers, okay. So if you're familiar with Kubernetes. Right? If you're doing AWS, it's Elastic Container Service. These containers have to be managed and they have to be orchestrated. They just can't run on their own. Okay? So now you got a bunch of overhead to manage this distributed nature of these containers that's running these applications that are microservices. Okay? And from a security perspective, more complexity that you have, more places that can go wrong. So more things become microserviced. Right? People are coming up with ways to finding the microservice that you have to talk to because they could be like all over the place. How do you find it? Automatically locating it. Okay? Then how do you know that what version of Docker containers and applications are running? I mean, because they're like all over the place. It's very easy to lose control over these microservices. So that's another security challenge, right? So we take away certain things that's bad, now we put in something new that's also going to cause problems, right? So if you're not a security person right now, I think still, security still has, plenty of place to kind of grow. Because I think for a while, all these things are going to cause problems, right? Because a lot of companies are just about getting started with taking their monolith and breaking it into microservices, okay? But a lot of people think that it's, well, okay, take a big rock and make it small rocks. It's not that easy. In fact, breaking a monolith into microservices is an art. It's not science. Okay? So if you do it wrong, you actually cause more problems. Instead of having microservices, you have a monolith that is distributed. Right? And when you have a monolith, one big piece, you broke it into little pieces so that you could do DevOps and you could do Agile and all this stuff. But if you maintain the relationship between these code, the dependencies, oh yeah, so that's probably the term I want to use, codependent, right? So these microservices probably become codependent, okay? They can't do anything without the other piece being there. Well, then if they're not separate, are they? So if they're not separate, you still have to coordinate whenever you want to make changes. Well, you were doing that before. Didn't you break it into pieces so that you don't have to coordinate, so that you can actually write these codes separately and you can move forward smartly, without talking to anybody else? Okay, that's the idea of DevOps. But if you don't do this microservices right, they're related, and now you got more problems. You just took the big rock and put strings, and then just kind of spread them around. Okay, so yeah, so it's not an easy thing to do, and. So when people talk about CI/CD, they talk about CI/CD pipeline. Because it's like dominoes. One thing happened, and everything kind of goes through the pipeline, and it comes out on the other end. So when it comes out on the other end, that's the running application. Okay? But when you're talking about security for CI/CD, I think, like I said, like a regular oil pipeline. I've never actually seen one. I'm just kind of, I just drew one. That's it. I used AI. That's mid-journey, okay? But anyway, so, you have the infrastructure, which is the pipeline. And obviously, you have to protect that, right? You have to protect the structure, okay? But things flow through the pipeline as well. You have to protect that too, right? You don't want to have it contaminated, right? You don't want people putting water inside the oil and stuff, all kinds of stuff, I'm sure, okay? Same thing with DevOps CI/CD pipeline. The CI/CD pipeline you create using tools, and they have to have good security, so not anybody and everybody has access to the tools. Can you imagine somebody hacking into your organization, and they get a hold of the DevOps pipeline, the CI/CD pipeline, and they start spewing out malware from your company? Or they'll take the one that's running, and they'll kind of mess up the code and still process forward? Or maybe they'll randomly stop your pipeline. All the things that could possibly happen in the oil pipeline can happen in CI/CD pipeline, right? Okay. So you have to protect access to these pipelines, tools, okay? Not even the inside thing. Then your application flows through, right? So your application, the source code, your artifacts, something that already deployed flows right through the pipeline. That also has to be secure, right? It has to be a good product. Okay. So when you're talking about security, there are like two facets to security when you're doing CI/CD. It's the security of the pipeline itself and security in the pipeline as well. So these are, two types of security. Okay. There you go, pipeline security. And, you do code security, pre-deployment security, deployment automation security, because automation, once it's broken, will start spewing out all kinds of junk. Right, out there, okay? So you have to be careful. All right, and the other thing, now, I'm kind of winding down, and the time is about that time. I want to talk about issues with security and CI/CD pipeline, okay? I don't think we're going to go backwards. I think we're just going to move forward. But I think we need to be clear-eyed about what are some roadblocks with the path that we're taking in general. Okay? So one, speed versus security, right? Speed kills, yes? Okay? And some things take time. And unfortunately, at this point, there are certain types of security testing that cannot be automated fully. that means you have to involve humans still, right? And if you try to avoid that, that means you're not doing that piece, okay? But with that said, it's actually called logical testing. So if you do mechanical testing, like, cross-site scripting stuff, you could just throw in certain types of patterns and it comes back and you could kind of tell if your application has those kind of flaws. But if you're thinking something like race conditions, right, that sometime it happens, sometime it doesn't happen, the timing has to be right, those are kind of hard to find. And the way programmers think, right? So if you have 10 programmers and you ask them to do, solve a problem, they'll probably come up with 10 solutions, okay? Some people have a great logical mind, some people won't. Some people write clean code, some people write spaghetti code, okay? So that means as long as there are those differences, the security tester also have to kind of fit and work in that space. So humans still programming, humans still testing. But like I said, probably within like 2 years, if not earlier, there's going to be more programs writing programs. That's going to be normal. Then programs are great at repeating patterns. And if there's going to be patterns, then security testers can recognize those patterns. And if the security tester is an AI, they'll be able to do that, right? So I think eventually, right, I'm kind of talking myself out of a job right now, okay? Yeah, but anyway, so that's the speed versus security. Automating security. Even now, for whatever reason, security tools actually had the short end of the stick when it came to automation. It took a long time, for whatever reason, for the security tool to become automated. But most of the tools that I was using before are now automated. Okay? And I never thought those tools that I was using would be automated, but they are now. Okay? So now we've kind of sort of caught up. I'm not sure if we're going to be able to keep up because things are moving more quickly. There are more tools. Right? There's so many. And once there are tools, you have to learn how to use them and stuff. Right? Shift left. Remember I told you, application developers being asked to do a security job? It's a nice concept. I just don't see it working in general practice. Okay? Unless you want the programmers to be a generalist. Right? If you want the programmer to be a specialist, security and development, not sure. Okay? So they probably, give them tools. Then they may be able to do that, right? And remember I told you about Code Guru? Give that tool to the developer. Yeah, I think that's going to go a long way. Okay? Complex integrations. Complexity breeds vulnerabilities. And systems are becoming more complex. Microservices, talking to microservices, over spread out infrastructure, distributed nature of the application, that's more complex. Cloud, mixing in with on-premises. People talk about multi-cloud, that's complexity, right? Trying to connect AWS with Azure, with Google Cloud, try it. Give it a try. I tried it. I said, oh, okay, that's for the birds, right? Okay, right now, because they're so different. And they need to be different to be special. But eventually, they'll probably become utilities, right? So now, because multi-cloud means that whatever underneath AWS, Google Cloud, who cares, right? As long as you give me virtual environment, as long as you give me all these things. That's the multi-cloud. And who wants to be that? AWS probably doesn't want to be that, right? So it's really like pulling teeth, right, to do multi-cloud. It'll probably happen. Visibility and reporting, things becomes complex. Look, people are now responsible for a little piece. And let's say that little piece was talking to another little piece and it was working okay yesterday, but all of a sudden something breaks and says, okay, I haven't made any changes. What happened? Must be somebody else, right? But you don't have visibility to what they did. So troubleshooting becomes harder, right? Once these DevOps start to get into place. Training and awareness, training, companies do it when they have money, when they have time, okay? And I'm telling you, I have very motivated people coming to my classes, right? But they're being pulled out, in middle of the class because they have to, fight a fire somewhere, or, they have another meeting. Life gets in the way of training, okay? And I wish they would make, training more like the military, right? You can't go home, you have to stay in one place and eat, I don't know, SOS, right? So I don't know if you eat SOS, but I love SOS. Yeah. And regulatory compliance, oh my gosh, right? So GDPR, have you heard about that, right? The privacy laws, oh boy, okay? And data has residency rules, so data cannot leave United States or data cannot leave EU, right? Well, the cloud, you get the benefit of the cloud because you find the cheapest place to put your data and run things. And if that cheapest place not becomes cheaper, you find another place and put it in. But now you put some constraints on that and says, no, sorry, you can't do that. You can't be moving freely around because, we have countries, right? Okay, and so you can't put stuff in the EU. You can't go to China, right? So you can't use AWS as China's data center for whatever reason. Okay. Anyway, so technology is there, but there are still a lot of constraints. And I just see, I don't know, I've been working in compliance too for a while. I just never see it going away. It just, people start to like pile things on top, right? And then I see customers that have to comply with like different compliance. It's crazy. Just depending upon your industry, you got like mountains of compliance, right? So, like I said, technology is there, but compliance is kind of hard to meet, okay? So anyway, to end my presentation, okay, and thank you so much for being so patient with me. The last slide here is, look, I'm an AWS instructor, right? So I just know a lot about AWS tools, right? I know a little bit about Google Cloud. It's not as big, as AWS. AWS is still number one still, even, beats Azure. But those folks actually have, similar tools, I'm sure. So I just want to introduce you to some of the tools. The automation tools. So DevOps proper, that is, something that you would use for DevOps and probably for nothing else, is Amazon Code Guru, right? It does SaaS, and something called a Profiler. It's really nice. So Profiler actually is an agent that gets put in to the production application. It monitors all the access. And then on top of that, not just like how many people are coming to my application and how busy am I on the server. No. It actually traces to see those requests going to specific functions. They say, okay, this application, this function is very expensive. This function is not running at all. What's happening with that function? Like, that kind of stuff. So now, using the profiler, you can optimize your code and say, okay, people are using this function, but it's not as, optimized, so let's go ahead and refactor that and fix it so it becomes faster. Right? So it gives you insight into the internals of the application. Yeah, I just love Code Guru. Amazon Inspector, it's a vulnerability scanner. It's okay. Right? It's getting better. It used to do vulnerability scanning based on the CVE, the Common Vulnerabilities and Exposures by MITRE Corporation. Right? So it used to do that on the EC2, which is a virtual machine. But now it can do it on the Docker containers. As well as on Lambda. And Lambda is a serverless compute platform. For those of you who don't know, what that is, that's okay. It's just, So what's common in all three cloud providers is that they have options for you to run your application. If you like to run applications on a server, you have a virtual machine environment. If you like containers, because they're more lighter weight, right? And because you're running more on the microservices side, then you got Docker environment. And if you care nothing to do with infrastructure, you just want to write code and just run it, then you have serverless environment. And in AWS, that's called Lambda. Okay? And other companies, they just call it something different. That's all. They all have them. Okay? On the infrastructure side, so this could be DevOps. It doesn't have to be DevOps, but these are all automation tools like AWS Security Hub, where you get all the warnings, all the bad things that are happening in your environment that AWS will warn you about. AWS Config, configuration management. CloudTrail is a API logging. Key management is management of encryption keys. Guard duty. So whenever I explain guard duty, I say, look, I used to be an MP. I used to do guard duty. I would stand on, out there in the post, driving my Jeep, right? Watching people, going speeding and stuff and, buying things that they were not supposed to buy and drinking too much out there. I was stationed in Korea. So we would go to bar runs and stuff, and making sure that all the soldiers are not, overdoing their alcohol. And then Amazon Macy. So if you're familiar with DLP, data loss protection, then Macy is for you, because a lot of companies, for whatever reason, they put their secrets, the really, really important secrets like passwords and customer information, and they put it into these shared folders that are open to the world. Right? So Macy will go in there and say, hey, you know what? Are you sure you want to have that like open to like everybody, like anybody? Right? Maybe it's a mistake, right? So they'll let you know. And WAF, right? Web Application Firewall. Yeah, that's my thing, right? So if you have an application that has a horrible SQL injection flaw, until you go and fix it, you put the WAF in front. So it's a firewall that is specific to preventing application type of attacks. So these are all automated stuff. And more to come, okay? And just put an AI on top of that, right? And that's where security is moving into. All right, everyone. So it's about 10:54. This class is supposed to be to 11, probably. I probably should have stopped talking 10 minutes ago. Sorry. Okay, right? But I got started late. Okay. I spoke a lot of things. I know some things are not your field for some of you. Okay. And I will provide my slides later on so that I hope you'll be able to access it. If you look up my name on YouTube, I'm not a YouTube person, but the company that I do webinar for, whatever I do, they put it up on YouTube. So I'm kind of embarrassed, but it's out there, right? So I'm out there, and look, I do ML, machine learning, AI. I do security. I do all kinds of stuff. In fact, I teach almost all AWS courses, right? So I'm just a know-it-all. What can I say? Okay, and I'm a security person at heart. So hey, thank you, everyone. I hope you enjoyed the content, and hope to see you again someplace. All right, thank you. Thank you very much.